Hello everyone, welcome to the lecture series of the Mathematics-01. Myself Hardik Patel from LJ Institute of Engineering and Technology. In today's session, we are going to start with a partial differentiation. Now, before we are going to define the partial differentiation, we are going on to the limit and continuity of two variable function. Now, first of all, what is a two variable function? So for that, a function f of two variable is a rule that assigns to each ordered pair x comma y in a domain D a unique number f of x comma y. Now, where if whatever the x comma y, it is belonging to the domain D, that is called the domain of a function f, and capital F, whatever the value of f you have at a point x comma y, the set of that is called the range. That means the set of x comma y such that xy belongs to D. Now we generally write it as z is equal to f of x comma y. That means if you are going to put a different values of x and y in xy plane, then you will get the different values of z in third dimension. And whatever the curve you have in three dimension or surface you have in the three dimension, that is your two variable function. Now here x and y are two independent variables. That means x is not depending on y and y is not depending on x. But z is a dependent variable and it is depending on x and y. That means your function is from r cross r to r, or you can say that your function is from r square to r. Now, going on to the example, sketch the curve f of x comma y is equal to x square plus y square. Now, basically, if you are going to draw the curve of x square plus y square, then it is like this. Here we have drawn this curve. This is basically a paraboloid. Now see, if you are going to put the different values of x and y, then you will get a different values of z. But they are all going to be in the form of simple paraboloid. So if you are going to cut it by some constant plane, z is equal to constant, then you will get a circle in that constant plane. Here the red lines are indicating the circle in the constant plane, z is equal to 0.2, 0.4, 0.6 and so on. Okay, this is simply for your understanding. This is here we are just defining how to we have shown that how to draw the graph of a three-dimension curve. Now we are going to define the limit. Now to define the limit, if f of x comma y is two variable function, then we say that limit f of x comma y, where x comma y tends to a comma b, is equal to L if and only if for any epsilon greater than 0, however small, there exists a delta greater than 0 such that mode of f of x comma y minus L is less than epsilon for all xy which satisfies mode of x minus y, x comma y minus a comma b is less than delta. That means, or you can write the same thing with a 0 is less than under root of x minus a whole square plus y minus b whole square is less than delta. That means we are taking a deleted neighborhood. Okay. Generally, we are not using the epsilon delta definition to find the limit. So for finding the limit at any point, we are going to consider the path approach. Now see, here in a figure, we have given 7 different paths which are going on to the point A comma B. Now see, there are infinitely many paths which are going to be passed from the point A comma B, correct? And they are approaching to point A comma B from different side. It is not necessary that you can assume this much path. There are infinitely more paths, correct? And if you have to find the limit, then you have to find the limit for all of them. If the limit for all the points exist, then and all are same, then you have a limit at a point A comma B. Now what we are going to do is, now instead of that we are going to use the simple approach. Suppose we are finding the limit at a point A comma B, and for that we are going to take a two paths as shown in a figure. Path 1, where first x approaches to A and then y approaches to B. In second path, first y approaches to B, then secondly x approaches to A. Okay, that means you are applying the limit where first x tends to A, then y tends to B, secondly first y tends to B, then x tends to A. And if both limit exist and are same, then we are going to check out whether the limit exists or not. That means if we are for a non-zero point a comma b, we are going to find the iterated limit x tends to a, limit y tends to be f of x comma y, and limit y tends to be limit x tends to a f of x comma y. If both exist at a point a comma b and are same, then we can say that the limit at a point a comma b exists. But at a point 0, 0, we are also going to check after iterated limit, we are going to check for y is equal to mx raised to n, where n is greater than 0 in any value which is greater than 0. Now, if you are going to put different values of n, then you will get different paths. Suppose we are simply putting n is equal to 1, that means y is equal to mx is a set of lines passing through 0, 0. Same manner, if you are going to put n is equal to 2, then you will have the parabolas y is equal to mx square. Okay. So if this will give you the infinitely many curves with one constant m, and if you are going to find the value of a limit using this one and the limit exists, then you will have a limit at a point. Okay, but suppose limit does not exist or your answer is containing the value m in the form of m, then the limit at a point does not exist. Okay, now we are going to start with an example. Before going on to example, what we are going to use the basic conditions. If your limit is not of the form 0 by 0, then we are going to apply the limit directly. But if it is 0 by 0 form, then and then only we are going to use iterated limit and concept of y is equal to mx raised to n. Suppose first question is determine the limit f of a function f of x comma y is equal to e raised to x square y minus 2y plus 1 at a point exist at a point 2 comma 1 exist or not. So what we are going to do, we are going to put the value limit capital L is equal to limit x comma y tends to 2 comma 1 e raised to x square y minus 2y plus 1 is equal to e raised to 4 minus 2 plus 1, and that will be directly e raised to 3, and this value is non-zero. So this limit is directly exist and it has a value e raised to 3. But in the case of second example, limit x comma y tends to 0 comma 0 e raised to x into sin y upon y. So in this case, if you are going to put the value, then e raised to 0 1, but sin 0 has a value 0 divided by 0, so 0 by 0 form is there. So what we are going to do, we are going to apply the iterated limit. That means first limit x tends to 0, then secondly limit y tends to 0. And vice versa, first limit y tends to 0, secondly limit x tends to 0. That means if you are approaching this, then in the first case, limit y tends to 0, limit x tends to 0, e raised to x into sin y upon y. And e raised to 0 has a value 1, so you will have limit y tends to 0 sin y upon y, and sin y upon y has a value 1 where y tends to 0. Same manner, secondly, if we are going to find the limit x tends to 0, limit y tends to 0, e raised to x sin y upon y, then e raised to x is constant with respect to the limit, so it will be going outside of a limit, and sin y now upon y has a value 1. Say, and then you will have limit x tends to 0 e raised to x, and that has a value 1. So in both cases you have a limit 1, therefore limit exists and it has a value 1. Okay. Evaluate the limit x comma y tends to 0 0 x minus y plus 2 under root x minus 2 under root y divided by root x minus root y. Now we are starting with capital L. This is 0 by 0 form, but we are going to use the simple method of 12th. If the factorization is possible and simple factors are going to be there, then we are going to use the simple factorization method. So if limit we are starting with a limit x comma y tends to 0 comma 0 x minus y plus 2 root x plus minus 2 root y divided by root x minus root y. Now for x minus y, we are going to factorize it in a form of root x minus root y into root x plus root y, and from second two terms we are going to common out 2, that will give you 2 into under root of x minus under root of y divided by root x minus root y. So root x minus root y will be common out from numerator and that will give cancel with the denominator, and the remaining term you will have is root x plus root y plus 2. And if you are going to put the limit x comma y 0 0, then you will have answer 2. That means there the limit exists and it has a value 2. Now determine whether the given function has a limit at its origin or not. So f of x comma y is equal to have x y divided by under root of x square plus y square for xy is not equal to 0 0 and is equal to 0 for xy has a value 0 0. That means function is defined in two parts. At a 0 0 function is a value 0. At a non-zero egg function is a value xy divided by under root of x square plus y square. So we are first starting with a iterated limit, that is first for path 1 limit y tends to 0, limit x tends to 0, xy upon under root of x square plus y square. And if you are going to put x is equal to 0 first, then you will have limit y tends to 0, 0 upon under root of y square, that will be a 0. And that will give you the answer 0. Same manner, secondly, first for path 2, limit x tends to 0, limit y tends to 0, xy upon under root of x square plus y square. And that will be nothing but if you are going to put y is 0, then you will have limit x tends to 0, 0 divided by x square, under root of x square, that will be a 0. And that's why you have a limit 0. So for both paths, you have a limit 0. So we are going to put now y is equal to mx. Now for path y is equal to mx, you will have limit x comma y tends to 0 comma 0 xy divided by under root of x square plus y square is equal to limit x comma mx tends to 0 comma 0 x into mx divided by under root of x square plus mx whole square. So x square common out from denominator and you will have x cancel out and that will give you mx divided by under root of 1 plus m square. So that if you are going to put the limit, then again it has a value 0. Same manner, now we are going to put y is equal to mx square. So if limit x comma y tends to 0 comma 0, xy divided by under root of x square plus y square is equal to limit x comma mx square tends to 0 comma 0, x into mx square divided by under root of x square plus mx square the whole square. And that if x square again common out from denominator and cancel out, that will give mx square divided by under root of 1 plus m square x square. Now if you are going to put the limit x 0, then you will have value 0. That's why the limit exists and it has a value 0. Okay, because for all paths we have a same limit. So generally we are going to check it for m is equal to x square, y is equal to mx square. Same manner, by considering the different path approach, show that the function f of x comma y is equal to x raised to 4 minus y square divided by x raised to 4 plus y square has a no limit as x comma y tends to 0 comma 0. So first we are starting with a path 1, limit y tends to 0, limit x tends to 0, x raised to 4 minus y square upon x raised to 4 plus y square. And if you are applying the limit of x, then you will have limit y tends to 0 minus y square upon y square. And minus y square upon y square cancel out and you will have a limit minus 1. This is the first limit. Same and for second path, we have limit x tends to 0, limit y tends to 0, x raised to 4 minus y square upon x raised to 4 plus y square. First we are going to put y is equal to 0, that will give you limit x tends to 0, x raised to 4 upon x raised to 4. And if it has a value 1. So in path 1 you have a value minus 1, in path 2 you have a value 1. So we have two different limits. That means the limit does not exist at a point 0 comma 0. Okay. Now we are going on to the continuity. Now for continuity of any function, a function is said to be continuous at a point a comma b if it satisfies the following condition. First one, f of a comma b exists. That means the function has a value at a point a comma b. Secondly, the limit at a point a comma b exists. That means limit x comma y tends to a comma b f of x comma y is equal to something else. And third, whatever the limit and whatever the value at a point, both are same. That means limit x comma y tends to a comma b, f of x comma y is equal to f of a comma b. Now note that every polynomial function is everywhere continuous. Please remember, if you have any polynomial function, then it is everywhere continuous. And secondly, every rational function is continuous everywhere except wherever it is not defined. That means wherever your function is not defined, other than that point, your function is everywhere continuous. This is simple. You have whatever you have learned in 12. Suppose you have x upon x minus 1, then that is not defined at my 1 because denominator is 0. So in that case, the function is not defined at 1. And therefore, you cannot say anything about continuity at that point. Okay. Now we are going on to the example. Determine the set of the points at which the given function is continuous. And f of x comma y is given by 3x square y divided by x square plus y square for xy is not equal to 0, 0. And it has a value 0 for xy is equal to 0, 0. So we are starting with a point not equal to 0. So for x comma y is not equal to 0, your function is defined in a form of rational and therefore it is continuous everywhere other than 0, 0. Now we are starting with at a point 0, comma 0. So first we are going to find the iterated limit y tends to 0, limit x tends to 0, 3x square y upon x square plus y square, and if you are going to put the limit of x, then you will have 0 upon y square, that is 0. Same manner, secondly, we are going to find limit y tends to 0, limit x tends to 0, limit y tends to 0, 3x square y upon x square plus y square. First limit of y is 0, so you will have 0 upon x square, that is again a 0. Therefore, we are going to put y is equal to mx. And if you are going to put y is equal to mx, then you will have limit x tends to 0, 3x square into mx divided by x square plus mx the whole square. X square common out and cancel from numerator and denominator. So that will give you limit x tends to 0, 3mx upon 1 plus m square. Again, if you are going to put the limit, then you will have a value 0. Okay, same manner, if you are going to put y is equal to mx square, then you will have limit x tends to 0, 3x square into mx square divided by x square plus mx square the whole square. X square common out from numerator and denominator, and you will have limit x tends to 0, 3mx square divided by 1 plus m square x square. Again, if you are applying the limit, then it has a value 0. That means you have a value 0 for all of the path, and therefore the limit at a point exists and it has a value 0. Also, the function has a value 0 at a point 0, comma 0. So the limit and the value at a point both are same. Therefore, the function is continuous at origin. And therefore, your function is continuous everywhere because at origin it is continuous and we have already written it is continuous everywhere else. Therefore, your function is continuous everywhere on a real plane, real xy plane. Show that f of x comma y is equal to 2xy upon x square plus y square, where xy is not equal to 0, 0 and has a value 0 for xy is equal to 0, 0, is continuous everywhere except the point origin. So again we are starting with a path 1. So path 1 is your y tends to 0, x tends to 0, 2xy upon x square plus y square. If you are applying the limit of x, then it has a value 0. Same manner for path 2, limit x tends to 0, limit y tends to 0, 2xy upon x square plus y square. Again it has a value 0. Now we are going to put y is equal to mx. So that will give limit xy tends to 0, 0, 2xy upon x square plus y square. That means 2x comma limit x comma mx tends to 0, comma 0. 2x into mx divided by x square plus mx the whole square. So that will give you the limit 2m upon 1 plus m square because x square cancel out. And since there is no x, so your answer is in the form of 2m upon 1 plus m square, which is depending on m. That means if you are going to substitute the different values of m, then you will have a different limit. That's why this limit does not exist. And the limit does not exist at origin. Therefore, your function is not continuous at origin. Now, we are going to check the continuity by simple substitution method. Let x comma y is equal to a comma b is not equal to 0, 0 is any arbitrary point. And if you are finding the limit x comma y tends to a comma b f of x y, then you will have answered 2ab upon a square plus because b square, because denominator is non-zero, so you can substitute the values directly. And that's why this value is non-zero, so the function is continuous everywhere except the point 0 comma 0. Okay, so these are the topics which we have covered in this session. If you have any query or any doubt regarding this topic, then please feel free to contact me. Thank you.